Solar activity is approaching its peak, and it might be as dangerous as it sounds. Scientists think it's likely to begin by the end of the year 2023, and that's years before it was predicted to start. From a distance, the sun seems to be calm and steady, but if you zoom in, you'll see that its surface is constantly seething and churning. It keeps transforming from a uniform ocean of fire to a chaos of warped plasma and back again in a repeating cycle. Every 11 years or so, the magnetic field of our star gets tangled up. Imagine a ball of tightly wound rubber bands. That's what it looks like at such moments. And then, at one point, it snaps and flips completely, turning the North Pole into the South Pole and vice versa. Right before this event, the sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emit powerful streams of radiation, and grow planet-sized spots. This period is known as solar maximum. It's a rather dangerous time for Earth since it gets regularly hit by solar storms. Such storms have the potential to disrupt communications and damage power infrastructure. Even worse, solar storms can harm astronauts working in space and even make satellites crash into the planet. At first, experts were sure that the current solar cycle would reach its peak in 2025. But judging by recent numerous sunspots, intense solar storms, and some other rare solar phenomena, solar maximum is likely to arrive as early as the end of this year. At the same time, most forecasts predict that the current cycle might peak in late 2024, and it's still 1 year earlier than NASA and NOAA had expected. During this maximum, around 185 sunspots will appear every month. But that's not too bad. Such a cycle is considered quite average compared to the historical record. The current cycle, which is the 25th since people started to record them in 1755, began in 2019 and was supposed to be really mild. You see, solar cycles vary in intensity. The weakest ones on record produced fewer than 100 spots per month during their peaks, and the strongest could produce more than 300. Why do the latest estimates differ so much from the initial ones, though? The thing is, it's still pretty difficult to forecast solar cycles. Plus, don't forget that we only have 25 cycles on record. It means the amount of data available for computer modeling is quite limited. These days, researchers explore alternative ways of predicting the behavior of the sun. They're based on the star's magnetic activity. Scientists have found out that the strength of every next solar cycle depends on the time when the magnetic field of the previous cycle vanishes completely. This event is known as the terminator. The terminator doesn't happen exactly at the solar minimum. No, it might still be up to 2 years till the next solar cycle starts to stir, waking up slowly. At the solar minimum, the magnetic field of our star is powerful and well organized. There are 2 distinct poles, like the ones a regular dipole magnet has. This magnetic field contains the sun's superheated plasma close to the surface, suppressing solar activity. But at one point, the magnetic field starts getting tangled again. Some regions become more magnetized than others. With time, the sun's magnetic field weakens. Solar activity starts to increase. Plasma rises from the surface of the star, forming giant magnetized coronal loops, peppering the sun's lower atmosphere. These horseshoe-shaped fiery ribbons then snap when the magnetic field realigns, releasing bright flashes of radiation and light. Those are solar flares. These flares often bring about huge magnetized clouds of fast-moving particles, coronal mass ejections. A few years after the solar maximum, the sun's magnetic field flips. That's the end of the solar cycle and the beginning of a new solar minimum.
We've sent more spacecraft to study the local environment on Mars than on any other planet. We have no evidence that life exists on the red planet or ever did. But that didn't stop some people from wondering. Mostly because of the pictures that NASA's Perseverance and Curiosity rovers take regularly of Mars' surface. Feel free to check them out for yourself on the internet. They're free for anyone to see. Over time, some odd shapes have appeared here and there in these pictures, making some people believe there is some sort of creatures living there already. Back in 2008, one of the rovers took a picture of a rock that looked very much like a female figure. Other photos seem to show animal-shaped figures, utensils, or other Earth-like objects. Again, there is little to no proof of this theory, as rocks can be of all sorts of shapes and sizes. But if you look at the pictures, it does make you wonder. A lot of people in the scientific community do see Mars as a better place for long-term settlements, even though our moon is closer. Firstly, because it's believed there is indeed water on Mars. It's just stuck in underground frozen lakes. The soil doesn't seem to be rich in nutrients, and it may have some harmful chemicals. Moreover, on the red planet, the gravitational pull is only 38% of Earth's, so it's easy to carry heavy objects here. On our moon, for comparison, the gravitational force is only about 16 and 6/10% of that found on Earth. We already have people studying how we might live on Mars right here on our planet. It's because certain regions of Earth closely mimic the harsher conditions on Mars. Devon Island, for example, is the biggest uninhabited island on our planet, located in the Canadian Arctic archipelago. It's easy to see why it's hard to live here. The soil stays frozen all year. The eastern part of the island is covered by a thick ice cap all year round. Summers here only last for less than 50 days and aren't really that warm. Not a lot of plants can grow here, so no animals can adapt to thrive and multiply. As such, the Hutton Mars project started here in 1997 to offer astronauts unique studying opportunities. There are few options here in terms of logistics and transportation, and communicating with people living outside the island is also a bit more difficult. All because of the temperature and barren soil. Think about it, if we can find solution to live here, we might be able to do it on Mars too. Regardless of our local training, the conditions on Mars are currently inhospitable. That's because it's really cold. On average, the temperature is about -81 Fahrenheit. Even during the summertime, it's never hotter than 86 Fahrenheit. And to top it all off, the planet's atmosphere is made of 95 and 3/10% carbon dioxide, so there's literally no way we could breathe there without special devices. Mars also lacks a magnetic field on its surface, so it is attacked by the sun's radiation. Because of the temperature variations, Mars often experiences powerful dust storms, which can surround the entire planet. Technically, these storms can physically harm us, but the dust might clog electronics and render solar-powered instruments unstable. We know now that life as we know it is impossible on Mars, but did it ever exist there? This is a question long debated by scientists, since NASA's investigations have determined that some parts of Mars were habitable at one point. We don't know for how long or how far back, and just because something could have lived there, it doesn't mean it actually did. Other recent photos from Mars showed a cloudy sunset. Does that mean it also rains on the red planet? Well, not really. For starters, on our planet, clouds are water vapors, and once it starts to rain, the water reaches the surface of our planet in liquid form. This process isn't the same on Mars. Surprisingly, there is more water in Mars clouds, but they're made of iced water. Think of them as a tiny icy fog. Combined with the thin atmosphere and cold temperatures, it keeps the clouds from ever falling to the surface. Sunsets are different here too. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars, so the sunsets here have more of a bluish tint. Similar to Earth, Mars is also tilted on its axis, which means it also has seasons. Because the southern hemisphere is directed away from the sun when Mars is farthest from it, the winters here are far colder and summers way hotter. Calendars work differently on Mars too. A year here lasts for about 1 1/8800th Earth years. A day is a bit more longer than 24 hours. Even if we were to ever move to Mars, we'd still have to communicate with our Earth. It would be a bit difficult to do, since a message sent back home would take about 15 minutes to reach its destination. It's not that bad given the entire distance, but it would make video calls kind of annoying. As difficult as it might be for now to live there is a lot of stuff to see. Some scientists believe that if we were completely colonize Mars, a list of locations would soon be declared national parks, like the area surrounding Olympus Mons, which is the biggest known volcano in the solar system, stretching over 16 miles. Valles Marineris would be another cool location. It's been a huge complex of valleys about the distance from Los Angeles to New York. Mars also has some cool polar ice caps, which sometimes experience dry ice snowfall. Saturn and Uranus are unique planets in our solar system because of their rings. It may not have one now, but Mars may be getting a ring of its own in the future. Don't get too excited. It's estimated it might take 10 of millions of years. Mars' largest moon, named Phobos, will be torn apart at one point. The debris resulting from it will settle in a rocky ring around Mars, resembling that of Saturn and Uranus. Speaking of moons, Mars has two of them that we know of. Apart from Phobos, there is also one more object called Deimos. Both were discovered by an American astronomer named Joseph Hall back in 1877. The scientist had almost given up his pursuit to find Mars moons, but thankfully he was urged to continue the project. The next night he stumbled upon Deimos. 6 days after that initial finding, Hall found Phobos. These two space objects may be in fact some asteroids captured by Mars gravity. Another theory suggests they formed in orbit around Mars at about the same time the planet came to be. The fact that Mars has a really weak gravity may also be the reason for this fascinating event. Mars was hit by large asteroids many years ago, just like our planet was. A lot of that debris surely went back to the surface, but some of it was ejected back into space, as Mars' gravity wasn't strong enough to pull them back. They had quite a journey, some of them even ended up on Earth. These pieces of Mars also helped us understand the planet's unique features. We've continued to send robots to the Red Planet quite successfully in the past few decades, but it still remains quite difficult to imagine people will soon land on Mars. Even considering the current rocket technology, the journey would take us 6 months. And that's an optimistic scenario, given everything goes well on board. After landing, humans will be exposed to deep space radiation and microgravity. Both of these have serious effects on the human body, which we've yet to figure out how to counteract. That's why research is continuously performed on the International Space Station regarding the long-term effects of microgravity.
Two bright beams of sunlight are traveling across your forehead, cheeks, eyes. Ooh, you scrunch up your face and sneeze loudly. It would be nothing unusual if the sun's rays weren't coming from two different stars. Yup, you're still on Earth, but this Earth has two suns. What would your life look like in such a world? It'd depend on the star's mass and their positions relative to Earth and each other. If the stars were small, their gravity wouldn't be enough to keep our planet in its orbit. It'd eventually drift away into space. But if one of the stars was larger than the other, it would have a much stronger gravitational pull, and sooner or later, Earth would end up too close to it. It'd become too hot to live on the planet. You know, boiling oceans, evaporating rivers and glaciers, and scorching hot air. Lovely. In the end, our once blue world would crash into the star and, disappear. The only chance for Earth to have a stable orbit would be to move around only one of the two suns. But it wouldn't be that great for all kinds of life forms on the planet. Every once in a while, the two stars would face both sides of Earth. It would mean there would be no nights. Our planet would get twice as much heat as usual. It'd also be bombarded with double doses of radiation. And of course, solar winds would become twice stronger. During such periods, you'd have to hide indoors and probably order drone delivery. Because you set your foot outside, the two suns would get you toasted in no time, what with all that heat and solar radiation. Uh-oh, it doesn't sound optimistic. Maybe it would be better if our planet was moving around both stars. Perhaps. Its orbit would be rather unstable in this case, and still, it would be better than experiencing crazy heat waves every now and then. But in this situation, the stars would have to be close to each other, and Earth would most likely travel too far away to get enough heat to keep its water liquid. If our planet had been developing in such conditions from the very beginning, now it would be just a frozen rock with no life on it. How about the most optimistic scenario? Our planet would get itself two similar-sized stars, and each of them would be more than half as powerful and bright as our current Sun. By the way, it sounds rather realistic. Such equal-mass double stars do exist. Their common gravitational pull would be just enough for Earth to not fly out into space, and the amount of energy our planet would get would be more or less the same as it receives now. But the combined mass of the stars would be about 1.5 times the mass of our current Sun. It would mean their gravity would also be stronger, and 1 year on the planet would be shorter. It'd last not 365, but around 280 days. But Earth would only feel comfortable if it was at least 4 times farther from its stars than they were from each other. Then our planet would happily move around their common center of mass. In other words, the suns would have to be less than 10 million miles apart. Then the rest of the planets in the solar system, including Mercury, would have stable orbits. If you lived on the Earth that was moving around 2 stars, you'd be able to watch awesome solar eclipses. But it would not be the moon blocking the sun, but one of the stars preventing you from seeing the other. Instead of several minutes, eclipses would last for hours on end. They would also occur much more often, maybe once in a week or so. If the stars were a bit larger in size, there would be 2 types of eclipses. Every now and then, a smaller star would block the larger one, but only partially. But when the bigger star blocked the smaller, it would result in a total solar eclipse, complete darkness. 2 suns would mean days would become brighter. Nights, sunrises, sunsets, these would change too. The star would set and rise at different times. So, arriving too late to watch the sunset? It wouldn't be a problem. You'd still be in time for the second one. With 2 suns, the seasons on Earth might also start to change more rapidly. They would be harsher than now. Most life forms on the planet would be struggling to keep up with intense and fast climate changes. But returning to the combined gravity that would be stronger than what we have now. Because of this, everything on the planet's surface would look different. Trees would be thick and short, plants stiff and tough. Animals would be way bigger and sturdier. Their legs would be more massive to support their weight. It would increase due to the stronger gravity. People would most likely be bulky and short. Their bones would be thicker, either to withstand higher gravity or because of constant breaking and healing. Humans would also have stronger muscles, lungs, and hearts. Well, at least the gravity wouldn't double at once. If it happened, our planet's core would probably collapse on itself right away. Then it would release so much heat it would burn everything on the surface, like us. Even if the gravity was increasing gradually, adapting to this new world would still be a challenge. Buildings and bridges would collapse under their new weight. Planes wouldn't be able to fly. In any case, discussing what Earth would look like with 2 suns is nothing but a guessing game at the moment. But scientists know for sure that such planets do exist. Kepler-16b was discovered by the Kepler Space Telescope. The planet, the only one astronomers know about so far, orbits 2 stars. It has beautiful double sunsets and is around 200 light-years away from Earth. But this planet isn't a welcoming one. It's the size of Saturn and extremely cold. Kepler-16b is mostly made of gas. It might have a rocky core, but astronomers aren't so sure about that. The planet is also out of its star's habitable zone. That's the area where there might be liquid water. Plus, the stars are colder than our Sun and much smaller. One of them is less than 70% of our Sun's mass, and the other just 20%. That's why scientists are almost sure no life could survive in such a place. It's highly unlikely Earth could be developing in the same way, even if it was orbiting 2 stars. After all, our planet isn't a gas giant like Kepler-16b. But if this had somehow happened, Earth's fate would be very different now. The temperatures on the planet's surface would be lower than minus 100 degrees Fahrenheit. All water would be frozen, and the chances are Earth would never have turned into the blooming green paradise we live in. At the same time, our Sun might have had a companion long, long ago. It could be Nemesis, a theoretical dwarf star. If it had been a white dwarf, just a teaspoon of its matter would have weighed more than 5 tons. It's almost as heavy as an elephant. White dwarfs are extremely dense. They can be the size of our planet, but as massive as our Sun. Such a dwarf star could be responsible for several mass extinctions on Earth. Scientists think it could somehow affect objects in the outer solar system. It's the region which is home to giant planets, Jupiter, Saturn, Uranus, and Neptune, and their moons. Anyway, Nemesis could push different space bodies off their course. Then it probably hurtled them toward Earth, where they collided with our planet and caused terrible disasters. It's just a theory, though. Many scientists don't support it, and astronomers haven't found any evidence yet. But a 2017 study suggested such a star could exist in the ancient past. Even better, the researchers claimed each star, like our Sun, was once born with a companion. But even if Nemesis had existed all those billions of years ago, it would have broken free of the Sun's gravity quite early in its history, and then it would have wandered off into the Milky Way.